Hey everyone, welcome back. Today we are talking about a powerful architecture that's changing the way we build modern applications, microservices. And one of the key technologies that makes microservices work is REST. In this video, we will explore how microservices and REST APIs fit together, why REST is so widely used for communication in microservices, and what you need to know to build scalable distributed systems. So let's get started. First, what is microservices? What does this mean? A microservices or a microservice architecture breaks down an application into smaller, more manageable or independent services that can handle that each can handle a specific function. For example, if we have one microservices that might, for example, if we have a client here and it sends a request to the server, we will break down our application into small services. So we have one service that handle authentication, and other one that handles orders, other one that handles the products, etc. So, so we have one service that might handle user authentication, and other one takes care of the payment, and other one takes care of the orders, etc. What makes microservices powerful is that they are loosely coupled and independent deployable, meaning you can update or scale individual services without affecting the rest of the system. This is why it's widely used. So let's talk about the rule of REST in the microservices architecture. So where does let's think where does REST come into play? So in microservice architecture, each service often expose a RESTful API or a REST API that other services or clients can interact with. REST simplifies or simplicity and statelessness make it perfect fit for microservices because REST is built on standard HTTP protocols. It's easy for services to communicate with each other over the web regardless of the language or platform they are built on. Number four, we have the let's talk about the advantages of using REST. Like, okay, we know right now the rule of the REST in the microservices architecture. Let's talk about the advantages, like what we get from that. So the advantages. Let's see the advantages. So one of the biggest advantages of using REST in microservices is platform independence. So REST APIs can be consumed by any service no matter what programming language or platform they are built on. This makes it easy for teams to build microservices in the best language for the job without worrying about the compatibility at all. Number two, number two, I would say the statelessness. So REST statelessness is perfect for scalability since each request is independent. You can easily scale microservices horizontally by adding more instances of a service without worrying about session data or stale data being shared between them. So another benefit also is flexibility because microservices expose their functionality via RESTful APIs. You can easily update, replace, or scale individual services without affecting the rest of the system. This modularity makes it easy to iterate on your service or on your services as your application evolves. Number five, I guess, how the microservices communicate with REST. So let's say that we have an authentication service and we have an order service or payment service, how these services will communicate with each other. So let's just try to imagine an example with the order service, and let's say that let's make this an inventory service. An inventory service. So when user place, let's imagine that user places an order. So when user places an order, the order service needs to check if the item is in stock or not. So it makes an HTTP request to the inventory service, and the inventory service might respond with 200, which is, oh no, this is too much. With 200, which is OK if the item is available, or 404, which is not found if it's out of stock. This kind of microservice to microservice communication is backbone of REST in microservices. Number 6, we need to talk about the challenges. Ta ta ta. So, one challenge of using REST in microservices is latency, because every HTTP request, sorry, because every HTTP request between services introduces a bit of delay, and this can add up when multiple services are involved in handling a single request. To reduce latency, you can minimize the number of service calls or implement caching to avoid unnecessary calls. Also, there is a reliability problem, because another challenge is reliability, because if one microservice goes down, it can cause failure in other services that which are relying on. To handle this, you can implement circuit breakers and a fallback mechanism. A circuit breaker temporarily stops requests to a failing service, and a fallback mechanism can provide a default behavior in case of service failure. Also, there is a distributed tracing and debugging, because finally debugging is more complicated in microservices architecture, because a single request might pass through multiple services. To solve this, you can use distributed tracing tools like Zipkin or Jigger to track requests across services and find where issues are occurring. I guess we can next talk about the best practices for using REST in microservices. Um, Practice. Yep. So when using REST in microservices, we need to follow these practices. First, we need to design with loose coupling so that service can be changed independently. Always return the right HTTP status codes for better error handling. We need to implement rate limiting to prevent services from being overwhelmed by requests. And of course, we need to document the APIs using tools like Swagger or OpenAI to keep everything maintainable. And finally, always secure your microservice within OAuth or GW token to ensure only authorized services can access your API. So in this video, we explored how REST and microservices work together to build scalable, flexible systems, and we looked at the benefit of challenges of using the benefits and challenges of using REST in a microservice architecture. So that's it for this video, and see you in the future.